Let's do number 3. Set up, again, but don't integrate, an integral for the volume of a solid whose base is bounded by these equations and whose cross-sections are squares perpendicular to the x-axis. So I have actually already drawn in and sketched these two equations so we can see the area we're dealing with. And we're going to want cross-sections that are squares perpendicular to the x-axis. So something kind of like this. So you get this shape going on. Okay, I need an integral. This is perpendicular to the x-axis, so my limit should be in terms of x. And I need to do the integral of the area of the cross-section. These cross-sections are squares. So the area of a square is going to be this length squared. That's the area of my cross-section. So I need to do a couple things here. Number 1, I need to figure out exactly where my points of intersection are so that I have my limits. If you remember from last time, we do that by setting these two equations equal to each other and then solving. And that will give us our intersection points and that will give us our limits. Then we need to do, for the area of this blue line, the top equation minus the bottom equation. And that will give us S, that line. So I can do that right now. The top equation is negative x squared plus 2 minus my bottom equation is x. And all of that squared, because we're doing a square, s squared. Now, as for finding the limits, I would like you to pause the video, solve this algebraically by bringing everything to one side and factoring, and finding out what your limits are. Once you know your limits, that means you're done, because we've set it up, we didn't need to actually integrate it. So pause the video and try to finish up this problem on your own. Ready, set, go. Welcome back. Should have gotten limits of negative 2 and 1, and that's our integral. Now, to end off this video, let's visualize this. So here's our curves right here. Got cross sections perpendicular to the x-axis, and I've got square cross sections here. If I take this one and start to tilt it, you can see all of our squares to give us our 3D shape. So we take that area, take the integral of those squares, and that gives us that 3D shape. Okay, that's it for problem 3. In the last video, we'll do problem 4, and then we'll be done.